All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. I know some of you are like, what is that, Mr. Q? Oh, yeah, students trigonometry students. Let's go, Jaden. So warm-up 108 is on the screen. Get started, please. I'll give you a head start so you can copy and start working on some of them. Some of them that might be unfamiliar, I'll go over those. So let's get cracking. And today we're moving on, by the way, so get a Cornell note right after. Set up, please. Go. All right, y'all ready? Y'all ready? Yes, let's go, Alex. We got this. All right, so I'm going to go ahead and get us started just for the sake of time. We have a lot to cover. And as promised, we are moving on. We're done with all those simple little functions that we've covered with rationals and such. Come on. Let's go. We're already fourth quarter. Let's do this. I'm going to zoom in for number 1. Here it goes. Okay. What's that? All right. Anyways, number 1A, 3 to the negative 2 power. What'd you get for that, Diego Romo? 1/9. That is correct. How about for 1/3 to the negative 3rd power, Diego Rosas? 27/1 or 27. How about for part C, Mr. Q? Okay. So this 3, before it was outside of the square root, it was inside of the square root. What number was it inside of the square root? It was a 9. Is that correct? Square root of 9 is what? 3. But what's already inside of the square root? 5. So what is 9 times 5? 45. There you go. Number 2. What'd you get for this part, Frida? That is correct. 2 to the x over 8. Number 3. I think we did some of this at the first semester, and I'm bringing it back. Here it goes. And this is a review for Algebra 1. Whenever they give us an exponent of a fraction, such as this one, this becomes square root of 81. How do you know, Mr. Q? Because I said so. However, look up. Here goes the rule for square roots. What is the rule? What number times itself 2 times? How do I know it's 2 times? Because it's here on the fraction. There's an invisible 2 right here known as the index. So what number times itself 2 times gives me 81? That number is 9. All right. That means that 100 is what, guys? 100 to the square root, which is what? 10. And once again, what's the rule? Well, the index is 2. That means what number times itself 2 times give us 100. That is 10. However, look at part C. Do you see that it's not about the same? So I'm going to rewrite it. Check this out. 8 to the 1/3 times 2. Do you agree that 2/3 is the same thing as 1/3 times 2? Yes? Okay. This is almost looking like that one. So watch. If 1/2 is square root, what do you think 1/3 is? Yeah, cube root. Cube root. However, we still have that exponent of 2 left, this one, and I'm going to put it right there. So What is cube root of 8? What does that mean? It means what number times itself 3 times give us 8? What is that number? 2 to the exponent of 2, which is 4. Woo-wee! Fun stuff, right? Am I right? Am I right? All right, number 4. Some of you already graphed it. That's fine. I'm going to come back to that just for the sake of time in a little bit once we get started with the lesson. But I do want to get to our trigonometry. Students, trigonometry students. Now, trigonometry is based, these trigonometric functions are based on a right triangle. Do you guys see the right triangle here? Yes? All right, so let's just identify where we're at with the right triangle. This is the 90-degree angle. Across from the 90-degree angle is the longest side. That longest side, so you remember, if you remember what that name is, what is the name of that longest side? Yeah, hypotenuse. Hypotenuse is the longest side. All right. What else do we know? We have 2 more sides, this one and that one. They're called legs, but for right now they just are called sides. Okay. The other thing, this triangle is labeled A, B, and C. However, those letters are at the vertices or at the corners, also known as angles. This would be angle A, this would be angle B, and this will be angle C. Does everybody see what I'm doing here? Yes? All right. And last, let me clarify one more word. Another word that we're going to need is known as adjacent. Adjacent. That's a uncommon word. Adjacent the only thing that you need to remember is that it means next to. Next to. What does adjacent mean? Next to. Okay. So now that we got that, let's get started with our trig functions. The first thing I do is set up fractions for each of those. Here we go. Let me scroll down. All right. So I'm going to start with sine. I'm going to do that in blue. Sine. So I'm going to write, shorthand is S-I-N equals, and we need a fraction. What is the fraction? Opposite over hypotenuse. So I'm going to write op over hype. All right. From there, I'm going to go to cosine. Shorthand is cos equals, and what does it say? Adjacent over hypotenuse. Adjacent over height. And last but not least, I'm going to go to tangent, also known as tan. Fraction opposite over adjacent. Opposite over adjacent. Once we have our fractions and our equation set up, now we need to look at what angle they want us to focus on. So let's go and let's see, what angle are they asking us to focus on? Angle what? A. So you're going to circle angle A. And you're going to be looking at each equation through the lens of that angle. Okay? And once again, look up, please. Each equation has 2 sides. It has a left side, which refers to the angle, and it has a right side, bless you, that refers to the sides of the triangle. Sides. Sides. The left side is the what? The angle. The right side is the what? Sides. Okay. Start with sine. So they want us to reference angle A. So I'm going to write sine angle A. Write that down, please. Here we go. And then we go with the side. This says opposite side over hypotenuse. So let's go to our angle A. Here's my angle A. What side is opposite to this angle? No, B is another angle. I'm talking about sides. What are my sides? 3, 4, and 5. Those are my sides, yes? Which one is opposite to angle A? 3, that is correct, so we write 3. And what is my hypotenuse? Because it says over hypotenuse. 5. And we're done with sine. Let's go to cosine. cosine angle A. That one says adjacent, or what side is next to angle A. 4, that is correct. That's right next to it. Yes. Over the hypotenuse, which is 5. All right. And last but not least, tangent angle A. What does tangent angle A say? Opposite over adjacent. Tell your neighbor what you're going to write for that. Who got 3 over 4? Hands if you got that. All right, students, trigonometry, students. Fairly simple, straightforward, yes? All right, copy the agenda, please. Warm-up 108, exponential functions, 4 transformations tonight. Now, just FYI, we're getting closer and closer to binder checks, and I'm going to be also looking at the, make sure that you're keeping up with your notes, your warm-ups and all that. That's 25% of your grade only. So once again, we finished warm-up 108. We're moving on to exponential functions, and tonight's home plate, 4 transformations and their graphs only. Last night's home plate was pages 413, 414. That's free from me to you. Now, within last night's home plate, if you recall from the lesson, there were, what did we do? We started with factoring, identify giant ones, and so on and so forth. So let me ask you a question. What if you factored and you couldn't eliminate any giant ones? What do we need to do? What did you do, JP? What's that? Did we hear that? We said that if you can't identify any giant ones after you factor, you go back to the original and use long division. So you remember what I just said? Yeah, long division. So basically, last night's home plate, even though we did have some of them from yesterday's lesson, I gave you a couple of them that had practice from the previous night. So, all right. So with that said, tonight's home plate, take a picture, please. It's on the screen. So I'm going to give you that function, and you need to do 4 transformations. You're going to see that after today. You're going to be like, oh, yes, I love these. All right, good. All right, y'all ready? Here we go. Our objective for today, I can graph and write exponential functions. I can graph and write exponential functions. I can graph and write exponential functions. Tell your neighbor the new concept for today. Yes, exponential functions. Exponential functions. That goes in the center of your prayer model. What are exponential functions? They are a function written in the form f of x equals b to the x, or g of x equals a times b, x minus h exponent plus k, where b is greater than 1, not equal to, b is greater than 0 and not equal to 1, and x is a variable. Should be almost done copying that, huh, JP? Yeah, good, good. Examples, copy those. All right, writing utensils down, look up to the screen. Here we go. I'm going to break it down. Ready? So, let me zoom in really quick. So, it says in the definition for exponential functions, it's a function in the form f of x equals bx. Have I given you those functions? Yes, I gave you these functions 3 weeks ago on the warm-up, yes? However, the base was a 2 or a 10. Is that correct? So from now on, I'm going to refer to this number as the base. And what do we know? According to the definition, it says that it has to be greater than 0, but not equal to 1. So what are they implying here? That the base has to be a number. The base has to be a what? A number. Okay. What else do they say? X is a variable. So what are they implying? That the X has to be, it has to be a variable. Could it be a number only? No, it has to be a what? A variable. You're like, Mr. Q, so if it has minus something else, doesn't matter what it minus, as long as it starts with a variable. We good? Once again, that's the exponent. Base, exponent. The base has to be a what? A number. Let's see if it's true with the examples given. Here we go. Is the base a number? Yes, Mr. Q. How about here? Yes, yes, and yes. Is the exponent a variable? Yes, 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 and yes. Why are they functions? Why are they functions? Because of the equal sign. Okay. Pretty straightforward, yes? All right. So with that said, now that we know what they are, look at those. Before you write them down, explain to your neighbor why this one and this one are not exponential functions. Why are those not exponential functions? All right, help us out with this first one right here. Why is this one not an exponential function? Caleb. It's got what? No numbers where? Here's the number. So the number has to be where? Let go. So the base does not have a number. That is correct. And what did we say? That all of these do have a number for the base. Okay. What else on that same one? Why is it not an exponential function? Diego Rosas. Exponent is not a variable. That is correct. All of these have a variable. All right, and the last one, why is this one not an exponential function? Isabella. I'm sorry? There's no equal sign. That is correct. It needs to be equal to a g of x or f of x. That's why it's not. So, with that said, what would be a hashtag, guys? What? All right, for the sake of time, there they are. Hashtag has to be a function or equal sign. Second one, it has to be a base with a number, not 1. And the last one, the exponent has to be a what? Variable. All right, so just revisiting where we started with transformations. Remember when you were baby algebra tours back in the third week of the school year? Aww. I gave you guys this form and I said we're going to be building up upon that for different functions. So let's remind everybody what each parameter does. What does K do, Diego Rosas? Up and down. And H? Side to side. And A? Stretches or compresses vertically. How about B? Stretches and compresses horizontally. That is correct. Under that same lens, copy our new function. g of x equals a times base b to the exponent of x minus h, close parentheses, plus k. And once again, what does k do again, Diego Rosas, just to make sure everybody sees it through the same lens? Up and down, h, side to side, b, stretch and compress horizontally, and a, stretch and compress vertically. Okay. However, for today, circle K in red. Circle K. Ha ha ha. See what I did there? Circle. Never mind. That one still serves a second purpose, and that purpose is known to us as an asymptote. Tell your neighbor which asymptote. Which asymptote, Briseida? Horizontal, that is correct. Or our HA, Y equals. Remember that? Yeah, that's still going to be working with that one. Okay? So, today we're going to be looking at exponential functions using this general rule for it. And I just want to get us started with the parent function, which I already gave you on the Freire model over here. Look up. 3 weeks ago, I introduced the parent functions, this one, and this one. Today we're going to be focusing on this one with base 2, okay? So, copy this down, please. Get that set up. Copy. I'll give you some time. Get a coordinate plane from -6 to 6 set up. Copy and go. All right. Now, check this out. Since I gave you plenty of practice on the warm-ups, by now this should be a piece of cake, right? Yes, Mr. Q. All right. So check this out. I'm going to start with the parent function, the very first exponential. Why is that a parent function? Because it starts with what? F of x. All right. So let's fill out that table. I'm going to use black for this one. So the base is 2. The exponent instead of x, now we're going to substitute what value? -2. Tell your neighbor what that is, please. 1 what? 1 over 4. That is correct. Let's write it again. Now 2 to the -1. What is that? 1 over 2. Everyone, what is 2 to the 0? Yep. 2 to the 1, 2. 2 to the 2, 4. And 2 to the 3, 8. All right, so to graph that, before we do, we always need to check for our HA. Tell your neighbor what the HA is for this one. Does it have anything at the end being added or subtracted? No, so this is 0. There it is. And that was number 4 on the warm-up. So let's plot our points. Here we go. -2 1/4, -2 1/4, -1 1/2, -1 1/2, 0 1, 1 2, 2 4, 3 8. And that 8, I'm going to make it an arrow. There it is. Students, exponential function, students. Now, why is this called an exponential function? Because if you notice, it starts growing pretty quick, doesn't it? Look at that. It just takes off quickly. Now, let me make an observation. From the beginning of the year till the function that we just finished, if you guys notice, Those parent functions always cross through what? 0, 0, and 1, 1. Is that correct? However, look at this one. This is the first parent function that does not go through 0, 0, or 1, 1. However, pay attention to this part. From now on, when I ask you to graph me the parent function f of x equals 2 to the x, I want you to use these 3 points. Ready? 0, 1, 1, 2, and 2, 4. Tell your neighbor which points are we going to use right away without a table? Yeah, so if I go like this, all right, guys, let's say I go Frida, f of x equals 2 to the x, and I give her the coordinate plane, and I ask her, help me graph that. What points do I use? One, 2, and what else? 2, 4. And that's how it's going to go. You start with that, and then you do transformations with whatever. Pretty straightforward, yes? All right. So, but let's go back to this. We have our points, negative 2, 1/4, 1, negative 1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. It's in that arrow. Okay. Now, if we look at this one with our general rule that we came up with, look up to the screen. Oh, sorry. Actually, I'm not going to put the F anymore. I'm just going to leave it as A, parentheses, base B, x minus h plus k. Look up or you're going to miss it. Here it goes. If I look at my parent function according to this transformation, tell your neighbor where we would move the whole function to. Where do we move it to? Jaden. Jessica, help him out. Move it to the what? To the right. That is correct. One step. Why? Because H right here tells us to move it to the right. All right, so I'm going to take each of these points and move it one step to the right. So I'm going to go 1 to the right, 1 to the right, 1 to the right, 1 to the right, 1 to the right. Do that as well, please. However, don't forget our HA. Does it have anything here being added or subtracted at the end afterwards? No, so it's still 0. All right. So, just for the sake to make sure that we are moving in the right direction, I'm going to test one of the x values. Let's see. I'm going to use the number 2 of x. Here it is, 2 of x. I'm going to substitute it in here. So I got 2 to the x minus 1, but instead of x, I'm going to write the 2. This is 2. What is 2 minus 1? That is 1. And what is 2 to the 1? 2. So, is there a point at 2, 2? Let's see. 2, 2. Yeah, there it is. So the transformation is working. All right. So with that said, look at this transformation. What would this whole thing do to the original parent function? Tell your neighbor, please. What is that going to do? What is that going to do? Delilah, what is this going to do to our original function? down 5, and 1 to the right. Hands, have you got that? That is correct. But before we do, look up. Tell your neighbor our HA for that one. What is our HA? Lorena. Close. Huh? -5. So let's go to -5. Plot our new asymptote. And then we're going to move all the points of the black function 5 down and 1 to the right. So I'm going to start 1 to the right, 5 down, 1, 1, 2, 3, 4, 5. This one, 1 to the right, 1, 2, 3, 4, 5. 1 to the right, 1, 2, 3, 4, 5. This one at the half, 1 to the right, 1, 2, 3, 4, 5. And this one, 1 to the right, 1, 2, 3, 4, 5. All right, from 1 to 5, I'll come to bar you with this. Yeah, we got this, right? What changed? What's the only thing that changed? The graph. That's the only thing that changes, guys. But the transformations are still the same. Okay. Put that on lock in your noodle. Copy this table. And that function, g of x equals 1/3 to the x power. And here's my table. And get another little coordinate plane on the side. I'll give you 1 minute. Copy and let's fill it. Here we go. On the side, right here. Oh, hold on. I'm going to write 1/3 parentheses. But now instead of x, I'm going to substitute my first value, which is -2. Tell your neighbor what that becomes. What'd you get, Julian? Hands, have you got that? That is correct. Let's do it again. 1/3 to the -1 power. What'd you get, Anaya? That is correct. Everyone, 1/3 to the 0 power. 1. That is correct. 1/3 to the first power is 1/3. And the last two, tell your neighbor what you got for the last two. 1/3 to the second power and 1/3 to the third power. Alyssa, the next one. 1/9. Alessandra, the next one. 1/27. That is correct. Let's before we plot those, tell your neighbor our HA for that one. Fabian? Very good. 0. So plot it there. There it is. Let's plot our points. -2, 9. -1, 3. 0, 1. 1, 1/3. 2, 1/9. 3, 1/27. And an arrow at the end. So let's see. What do you guys notice on this one? That it started up here and it's going downward. You guys notice that? Look at the previous ones. Look up. They started down and they went upward. Observation. Look at the base. What is this base? 2. Started down here and it went up. What is the base on this one? 1/3. It started up and it went downward. So what can we conclude? Talk it over with your neighbor. What can we conclude it with exponential functions? If the base is what does it do? And if the base is what does it do? All right. Oh, sorry. So write this down. Copy your general rule. Underneath the letter B in blue, I want you to write base. number. There's two options. What's our first option, Briseida? Very good. She said whole number. That's the first option. What does it do if it's a whole number, Lorena? It goes what? The graph? All right, let me go back to the previous one. Some of you were a little bit distracted. Here it goes. The base was 2, and it went up. This one, the base was a fraction, and it went down. Therefore, if it's a whole number, it goes up. That is correct. In other words, the word we use is growth. What is our second option for that, Fabian? Fraction or decimal? And what happens there, Diego Rosas? It goes downwards. That is correct. Or in other words, we use the word decay. Students, exponential function students. There's two types that we talk about. They're called growth or decay. So here's the home plate for tonight. Look up to the screen. For tonight, I gave you the parent function. Look up to the screen, you're going to miss it. F of x equals 2 to the x. Now, Frida's going to help us graph that parent function really quick in 30 seconds. What 3 points am I going to use, Frida? 0, 1. 1 what? 1, 2. 2, 4. 3, 4. And then I have to make up 4 transformations. How many? I'm going to make up one really quick so you guys can see it. I no longer can label it f of x. Now it's going to be g of x. And I'm going to use that same base with an exponent of x. So if I wanted to go to the left 3 steps, what would I write? Where would I write it? 3 steps to the left. Tell your neighbor, what would I write and where would I write it? Caleb, go. Three to the left. Very good. +3. Hands, have you got that? Yeah, that takes us 3 to the left. And then let's say I wanted to go 2 steps down. Where do I write that? Tell your neighbor. Yeah, 2 steps down. That would be one transformation. Let me give you another one. G to the x equals 2x. Let's say I wanted that one to go 4 to the right. Tell your neighbor what to write and where to write it. Caleb. -4, and then 3 steps up, I would write what? +3. I need 2 more. Does that make sense? Yes? All right. Give me another one. Tell your neighbor another one, please. And then I'll have Jose share his. Go, Jose. X minus 1. And where's that going? That is correct. 1 to the right, 1 up. And then 1 more for yourself. And anyways, don't copy these because these are mine. Oh, yeah, you have to make up your own. And this is being recorded, by the way, so if I see that you used any of these, then they're wrong. All right, from 1 to 5, how comfortable are you with these? 1 to 5, 4, 5, 4, 5. Okay, we'll stop right there. Or do we have time for one more? Nope. All right, we'll stop right there. And the home play for tonight is that parent function with 4 transformations. And, oh, today no tutoring, guys. I have a meeting after school. Enjoy your home plate. I'll stop the video right there. Bye.